This video presents the results for our entirely data-driven approach to cloth animation. Please note that all of the video you see here has been captured in real time. The garment worn by this character has 29,000 vertices and is being interactively driven by the game controller at 60 frames per second. We do this by pre-computing over 99,000 frames of cloth simulation. We first build a standard motion graph from recorded human motion, some of which is shown here. We then simulate clothing for each of these clips. Unfortunately, just storing a single cloth configuration for each pose yields poor results with jumpy transitions. Trying to blend out these discontinuities doesn't work either. The motion is clearly non-physical. For example, notice how the hood starts to fall off but then is non-physically pulled back onto the head. We can visualize the cloth data as this tree-like structure. Paths down the tree represent simulated cloth sequences. Each time we fall off a leaf, a gray link leads back to an internal node, causing a jumpy transition. Our method identifies the worst transitions, then begins to extend the tree by unrolling the motion graph and continuing these cloth simulations. This process, which we call continual exploration, not only improves the motion but also uncovers interesting new cloth behaviors. For example, notice that after simulating 4,900 frames of cloth motion, the hood falls off, only to be shoved back up again by a bad transition. Here we show error visualization on the right for this motion. Viewing the same motion sequence after simulating 11,000 frames, we still see the hood artifact. This is because continual exploration uncovered this new hood behavior, but not its aftermath. After simulating 36,000 frames, this hood now stays off, and the precomputation begins continually exploring each branch of this dynamical bifurcation in parallel. Nonetheless, we still see bad transitions in different motion. Finally, after 4,500 hours of precomputation, simulating 99,000 frames, these transition artifacts are all but removed, not just for this motion sequence, but throughout the graph. This comparison shows how the cloth quality increases as the precomputation progresses. These 99,000 frames represent 33 gigabytes of raw data, which we are able to compress into less than 70 megabytes using a combination of linear compression and quantization. The linear compression coefficients are visualized to the left of each panel. Here we see compression with 10 bases, 50 bases, and 200 bases. Note that 200 bases is comparable to the uncompressed data shown in the bottom right. We now show real-time capture of a user interacting with our system for a prolonged period of time. We have precomputed 2 full secondary cloth graphs, including one with layered clothing shown on the right. Thank you.